Hello all, welcome to next class. In this topic, I'm going to explain different types of Hooke's law, what are the mechanical properties, and elongation formulas, and the modulus of rigidity. See, this Hooke's law states that within the elastic limit, the stress is directly proportional to strain. That means, see, I have the stress strain diagram, stress and strain diagram. We are giving a properties of elongation test take place. So within the elastic limit, there is some proportionality is called stress Hooke's law. Stress is directly proportional to strain is represented as Hooke's law. See elastic constant. Elastic constant for a material, it obeys the Hooke's law. The ratio of stress to strain is constant. The ratio of stress to strain is constant. Depending upon the nature of the strain are three important elastic constants. These are the three important elastic constants. First one is modulus of elasticity, modulus of rigidity, bulk modulus. In almost all the subject, we have learned about this three important elastic constant. What is the elastic constant? For a material that obeys Hooke's law. What is Hooke's law? Hooke's law states that stress is directly proportional to strain according to the tensile stress. See, modulus of elasticity. It is a ratio of tensile or compressive stress corresponding to strain is called as modulus of elasticity, simply called E. See, we called this modulus of elasticity is simple stress by simple strain. Simple stress is P or simple strain is E. What? Simple stress by simple strain. And what is modulus of rigidity? It is a ratio of shear stress to shear strain. If we learn about the shear stress, it will be used. Shear stress to shear strain. It is denoted as G and C. It is also called as shear modulus. Modulus of rigidity, elasticity, modulus of rigidity. Rigidity will talk about shear stress area. And bulk modulus. It is the ratio of direct stress to volumetric strain. Later I am going to explain different types of bulk modulus, and it is represented as direct stress to volumetric stress. And factor of safety. For every material there is some factor of safety. That means a material can bear that much amount of the load itself. Beyond that it will be break. So for everything there is some safety. We need to understand for every even construction of a building, the material can withstand. See, I'm using a little bit diameter of the rods in the construction of the buildings. It can bear only that much of load. So if I want to construct 100 floors or 50 floors, I have to use a more amount of thickness of the rods on buildings. So why? Because if you have some safetiness, see, the ratio of ultimate stress to design stress or working stress is called factor stress. Ultimate stress, this is the stress which is a maximum amount of stress to the design stress is called factor of safety. See, factor of safety is ultimate stress to design stress. In some cases, structural factor safety is based on yield stress also. Which is very important, Poisson ratio. For every materials have some Poisson ratio. That means, see, there is a longitudinal strain to the, it is the ratio of lateral strain to the longitudinal strain is called Poisson ratio. Generally, it is represented as mu or 1 by m. What is the Poisson ratio is 1 by m lateral strain by longitudinal strain. Lateral strain, lateral strain or lateral strain like this. We represent this lateral strain along with longitudinal strain. This is comes under Poisson ratio, lateral strain by longitudinal strain. Hooke's law, stress is directly proportional to strain. These are very important topics we have to learn. And generally, in the Poisson ratio, the value is only in between 0.25 to 0.5. That means this is the range of the Poisson ratio. Beyond that, it will not be there. And next is mechanical properties. For every engineer, there should be known some mechanical properties. These are the very important to know about the mechanical engineer. Okay. Mechanical properties is associated with behavior of a material. Behavior of the material subjected to mechanical load. Most mechanical properties are used. See, for every material have some behaviors. In our world, in general scenario, we see many materials like plastics, glass, metals, non-metals, wood, everything which is related to these mechanical properties. As an engineer, we need to know what is a property. So if once we know the mechanical property, we can use any kind of works. Like see this is a have this is having some strength. If I apply the same load on plastic, it definitely breaks. In other cases, if I use the same load on glass, I want to break the glass, it will break. So for every material, some having mechanical properties. We'll go by one. What is a strength? Strength is defined as the capacity to resist external loads under given conditions. For every material have some strengths. Capacity to resist external loads. External loads it can resist. I mean it can be absorbed or it can bear. It is called stress. Beyond that it will break. And modulus of elasticity, it is a ratio of shear strain to shear strain, as I already explained. And ductility. Very important for the mechanical engineer is to know about the ductility. The ability of a material deform tensile load, this is called ductility. See, I have a rod of copper. I can increase its length by applying a load, tensile load. That is called ductility. I have a gold is have some ductility. Similarly, copper rod. So every material have some ductility. Most importantly, silver have most ductile material. And next, mild steel. Next, malleability. See, I want to insert a hole or insert a nail in some wall. We use this malleability, ability of material to deform under a compressive load. Due to this property, metals are hammered or rolled into sheets. See, I want to insert a small nail in the wall. So hammering I am giving. That hammering is called how? Malleability. Next is brittleness. See, I have a glass here. This will break if I apply a load. That is called brittleness. It will definitely break and may fracture due to the properties. Chalk piece, I will break it. There are many examples for the brittle materials. Hardness. Hardness, diamond. See, diamond is the hardest part of the material in the ever world. See, ability to material to deform under the compressive load, ability to material to resist absorption, stretching, indentation is defined as hardness. Hardness test to be also be done. Hardness, hardness test to be also be done. Next, resilience. Ability of material to store some energy within the elastic limit without a permanent deformation is called a resilience. I mean, store some energy within elastic limit is called a resilience without a permanent deformations is called resilience. Toughness. These are the different 14 mechanical properties: strength, hardness, ductility, malleability, brittleness, and now we have toughness. The ability of material to absorb energy before fracture is called a toughness. So for every materials have some fractureness. Glass will immediately break, but there is a time taken place between the fracture and a load that is called fractureness or toughness. And fatigue, the maximum stress under the varying load with material with operate identified without fracture is called fatigue. Maximum stress, that means it can bear the maximum strength, is called fatigue strength. And creep, see, this is slow and progressive deformation within the with the time constant is called a creep. See, I have a wall. A wall consists of some rod. That rod having using nails or bolts, nut and bolts. When apply a load on this rod, due to some transformation of take place and time taken, there is a uh, load taking place continuously. After 5 to 2 years, it will break. The slow and progressive deformation of material is called creep. So we'll recap once again what we learned: stress, strain, lateral strain, Poisson ratio. These are the topics which I have covered. Now we have to know the different variation of the composite materials. This is the rod 1, this is the rod 1, and this is the rod 2. By using a two combination of two rods, what is the load we are calculating? Say, considering member containing different cross-section areas of diameter d1 and d2, a length of L1 and L2, as shown in figure, let the section of subjected to point load P. So based upon these composite materials, we have to calculate the stress. Still now we learn what is the stress, what is the strain, what is Hooke's law, mechanical properties. Now these are the very important for the next upcoming classes. See, the stress elongation for the different cross section areas, like stress formula for the F1, I mean rod 1, stress formula for the rod 2, and elongation. What is elongation? How it come? So these elongations is strain. Hooke's law. Hooke's law states that stress by stress is nothing but P by A, and elongation sigma L by L. So here is the stress of elongation from formula. Total elongation in first materials, elongation in second material. The combination of both of materials, we have this formula: P by E L by A plus L2 by A2. This is the formula for the elongation of total length, and we'll use some problems related to this. Axial load of 25 kilonewtons acting on a ball consisting of two lengths of 250 mm and 330 mm diameter. Determine the Young's modulus ink small s, and determine the stress of. See, this is an example formula. That is, we are saying that length is 250 mm of two rods. Rod 1 is 200 mm, diameter is 30, diameter is 30. So, and that they are given a load of 25 kilonewtons. 25 kilonewtons. Similarly, diameter 1, diameter 2, length 1, length 2. What we have to find out in smallness, and in L smallness we are given, we need to find out stress. So for the diameter 1, we have the formula called pi by 4 d square. Area 1 will get. Similarly, area 2 will get. Next, for the stress 1, sigma 1, load by area. Load is given, area is we found, and similarly, stress 2, load by area. Combination of two stresses we need to calculate. What is elongations? Elongations, change in length by E. This is a stress, this is the length, this is the length, and elongations. We'll get elongations for the part 2 also similarly. So the combination of both elongations will get the overall elongations. This can be represented by composites materials, composite rods. So till now we'll learn different types of stresses, including the variation of cross sections, deformation of various cross sections. See, this is above formula used for total elongations for the cross section areas. So these are the topics I'm going to share with you. Composite sections consist two or more different materials rigid connected together. This is steel rod 1, steel rod 2, or copper rod 2. For different materials for different cross sections. See, composite means two or more materials. Initially we have only used one copper rod or one mild steel. Now this is a composite, means combination of two materials